recording. Let's read here. There's a green flag. You must score at least 70%. I remember 75%, but okay, 70% is fine. 70% before you can begin exam. Exam 2 covers chapters 8 and 9. We have 31 questions on the review. The actual exam 2, I remember I put 18 or 19, around that number of questions on the exam. Let's start it. Question number 1. Suppose that the local sales tax rate is 3% and you purchase a car for $12,900. Part A, how much tax is paid? Let me get a scientific calculator. Sales tax problem is a markup problem. You pay more than just the price of the car because you also pay 3% of the car price to the government, local government. The amount of tax amount equals tax rate times the item price. So we are going to multiply 3% with 12,900. 3%, 3 divided by 100 is 0.03. 3% times the price of the car, 12,900. So the sales tax on the car is $387. That's part A. Part B, the total cost. Total cost is the addition of the price of the car and the sales tax. So we add the $387 on top of the price of the car, $12,900. 13,287. While we are doing the review, we will not have the immediate feedback. But I guarantee those answers are correct, by the way. And we'll see after we submit the review. Question number 2. An exercise machine with an original price of $670 is on sale at 20% off. So this is a discount problem, marked down problem. 2 parts. Part A, what's the discount amount? Part B, what's the exercise machine's sale price? Part A, discount amount equals discount rate times the original price. So we're going to multiply 670 by 20%. 20%, 20 divided by 100, 0.2. Be very careful. If you are not sure, 20% as decimal is 0.2 or 0.02, you can just translate 20% in a calculator like this. 20% per means divided by, cent means 100. And the calculator will do this for you, all right? And also some of the calculators, TID4 doesn't have it, but some simple calculator, they have the percent sign here. If I enter 20, oh, this one, I don't know how, okay, try this one, 20, let's see. Actually, I don't know how to use that. 20, this is a percent sign, right? Do it again, 20. Okay, never mind. So 20% is 0.2. 0.2 times the original price, 670. That's the discount amount. That's the money, that's the dollars you save when you purchase the machine when the machine is on sale. Compare with you purchase it when it's not on sale, 134. The sales price is cheaper than the original price because it's on sale, right? So the actual selling price is going to be the difference of the original price and the discount. We use the original price 670 to minus the discount amount, the money you saved, $134. The difference is $536. $536. 36. Be very careful entering. Automatically, eventually what really matters is what you enter in the cell. Even sometimes you touch a key, you know, change it. Even you know the answer, but you messed it up. So be very careful what you enter in the cell. So that's question number 2. Mark down problem, discount problem. Let me know if you have any questions, all right? Yeah, let's see the whole image here. Question number 3. The bar graph shows that life expectancy, the number of years newborns are expected to live in a particular region, has increased dramatically since ancient times. Find the percent increase. Okay, this is a percent increase problem. In average life expectancy of the region from the Stone Age is the first bar, Stone Age, first bar, to 2016. 2016 is the last bar, okay? Yeah, what really matters is the first bar and the last bar. We are looking for percent increase. Remember I said when you need to process a percent increase or percent decrease problem, on your scratch paper, you need to write down. Let's get my scratch paper. You need to write down original and new. So on your scratch paper, you're going to write down original, new. We consider the life expectancy of the people living in that region. Original is the life expectancy in the Stone Age, which is 28, is the number on top of the first bar. And the new is the number on top of the last bar, which is 76. Yeah, make sure, please write this down. All right, so very naturally, you want to know from Stone Age to 2016, how many years, how much the life expectancy has gone up, has risen, right? So you want to use 76 to minus 28 to figure that out. And we have 48. So from the Stone Age to 2016, the life expectancy has risen, has gone up 48 years. And then we want to know the percent increase. Percent increase. We use the increased amount to divide by the original, very important. Divide by original, okay? And then multiply 100 and attach the percent sign. So that's what we do. The increased amount is 48 years. The increased amount is 48 years. Compare that with the original. So divide that by original. On your scratch paper, you have original is 28. Divide by 28. And you multiply by 100. And then you attach the percent sign. The percent sign is already there. You don't have to worry about that. You need to enter the value in front of the percent sign. And obviously, we need to round the result, right? Let's see the rounding rule. Round to the nearest integer as needed. Don't forget, this number is the number we need to round. This number is the quotient. We use 48 to divide by 28. And then we multiply 100. We already multiply 100. That's the number we need to round. Since this 4 is less than 5, so we rounded it down. Rounded down to the nearest integer, 171. We're going to enter 171 here. All right? So the percent increase is 171%. Compare with the Stone Age time, the life expectancy, average life expectancy in that area has gone up by 171%. All right, very important. You very likely would have this problem. I'm pretty much sure you're going to have this problem. And we already covered the problem. This is not the first time. Let's keep going. Question number 4. A sofa regularly sells for $530. The sale price is $466.40. Find the percent decrease of the sale price from the regular price. So this is about finding percent decrease. Same way as finding percent increase. On your scratch paper, you need to write down original and new. Original and new. Original, the regular price is the original price, right? $530. Originally, the sofa sells for $530. And the new price, after the discount, the sales price is lower. So new price is $466.40. You write down original and new. And then let's see how do we find the percent decrease on your calculator. You want to know from original price to the new price, how much the price has gone down, right? So you want to use 530 to minus 466.4. Yeah, 530 minus 466.4. And that's how much the price has gone down. It's gone down $63.60. And that's the decreased amount. This is the decreased amount. The price has decreased. The price has decreased by $63.60. Sorry. And we're going to divide that decreased amount by the original. Always divided by original. You're going to write it down, then you know what is the original. Trust me, if you do not write them down, very likely you mess it up. Because when you try to divide by original, you might, make a mistake. But once you write it down, when you look at the scratch paper, okay, I'm going to divide by original. Okay, on my scratch paper, I have original equals 530. That's the number I need to divide by. 530. 0.12 is the decimal of the quotient. And we're going to multiply that by 100 and attach the percent sign. So we have 12%. 12%. The price has gone down by 12%. All right. If you purchase $100 value of the sofa, and you save $12, that's what it means. 12%. If you purchase $100 originally $100 value sofa, and you save $12, now you only pay $88. That's what it means. Question number 5. At the time of her grandson's birth, a grandmother deposits $12,000 in an account that pays 8% compounded monthly. What will be the value of the account at the child's 21st birthday, assuming that no other deposits or withdrawals are made during this period? Assuming no other deposits withdrawals are made during the period, that means this is a lump sum investment. The grandmother only invests in the account for one time, the very beginning when she opened the account, drop $12,000, and that's it. Forget about it until the kid is 21 years old. So this is a compound problem. If you prefer to use the formula, our exam is closed book, closed note, but the system will give you the formulas, and you just need to know which one to use, and you use the first one. Okay, P is the original principal, that 12 grand. A is the value of the account in 21 years. But you guys know that I recommend we use TID for calculator, right? Okay, let me show you how do we use TID for calculator. Firstly, everybody, I want you to write down the key information for this problem. Deposits 12 grand. When the grandma opens the account, she is going to put $12,000 in the account. And you also please also write down the annual interest rate, 8%. Also write down your little n is 12 because the account, the interest is going to be compounded monthly. So please write down little n equals 12. And we are looking for the future value of the account in 21 years. So on your scratch paper, please write down t equals 21. Okay, give you a little time, because later when I pull out my calculator, TI-84 calculator, you won't see those. So on your scratch paper, please write down principal P is 12,000. The grandma put in $12,000. Interest rate 8%. Monthly, so little n is 12 for 21 years. All right? Okay. Yeah, we can use a calculator. We can use calculator, my TI-84 calculator. When do we use TI-84 calculator for the exam? For 3 different types of problems. This is the first type of problem that you may use TI-84 calculator to help you. This is the compound interest account problem. We go to apps, finance, TBM solver. So capital N, 12 times a year. So capital N here is the number of times the interest is compounded over the 21 years, not the 1 year. This is capital N, not your little n. I ask you to write down the lowercase n equals 12. But the capital N is n times t times 21. Make sure we understand this. Capital N here is the total number of times the interest is compounded over the lifetime of the investment. The grandma is going to invest his money for 21 years. So the interest is going to be compounded this many times, because 12 times a year for 21 years, 12 times 21. Interest rate is 8%. Oh, actually, it just happened to be 8%. It's coincident. And the PV, the grandma put 12,000 in the account the very beginning. So PV, present value, when the account just be opened, the account has $12,000. We do not have a payment, put a 0 here, all right? Because during the 21 years, the grandma just forget about it. No payment, no withdrawal. And future value is what we're trying to figure out. P per Y, C per Y is 12 because the interest is compounded 12 times a year, monthly. And again, this END, we always put END, highlight END. We never use begin. To solve for future value, clear, okay. Alpha, enter. So future value, do not worry about the sign. Negative, we can say that the money belongs to the grandkid, right? So do not worry about the negative sign. $64,028.69.9965. Let's see, how do we round it? Round to the nearest dollar as needed. Round to the nearest dollar. 6 here is bigger than 5, so we rounded up. $64,029. Okay, $64,000. $64,029. You're welcome to use the calculator, the formula. You should have the same result. All right, you should have the same result. So this is the first type of problem that you may apply the TI-84 calculator. Capital N, total number of times the interest compounded. 12 times a year for 21 years. So 12 times 21. I%, which is given. Present value is the lump sum the grandma put in the account at the very beginning. No payment, so PMT is 0. P per Y, C per Y, little n. P per Y, C per Y are little n, 12. And solve for future value and just round it up properly. Rounding is very, very important. in the past semesters, there are always students mess up the score of exam 2 because of the rounding. Even I have emphasized so many times. Seriously, I have emphasized so many times. I guess they never pay attention. So this is the enter when, okay, someone's asking, how do you find this program? Okay. Let me show you again. Can make it bigger actually. Our TID for calculator, I guess just this big. There's a key APPS, apps. And your handheld, my handheld calculator only have one app, is the finance. This is the one I need. I don't have those fancy ones. This is an emulator in a computer, so mine look a little bit different. So we use finance. You should have that in the calculator. And the first function is TVM solver. It stands for time value of money solver. That's the function we use. You should see this menu. Okay, very good. Let's continue. Question number 6. How much money should be deposited today in an account that earns 7% compounded semi-annually, such that it will accumulate to 11 grand in 3 years? Okay, so this is a compound interest account problem. If you are using the formula to solve the problem, this is the formula you are choosing. Second one, okay? Because this problem is to find the original principal, how much you invest in order to have a certain amount of money in the account in the future. So capital A, the accumulated balance in the future is given. You're looking for how much to put in today. So you use the second formula, all right? If you use the formula, then that's the formula. That's the formula. And T is 3 years. N is 2 because it's semi-annually, right? R is whatever the 7%. Yeah, and you just plugging in. And A is 11,000. And of course, we can use the TID for calculator. So please write down those key information. This is still an compound interest account problem. So please write down those key information. Interest rate 7%, semi-annually, so little n, little lowercase n is 2. Capital A, accumulated balance 11 grand, 11,000. Time T is 3. Okay, 11 grand, 7%. So in the TID for calculator, what we can do is this. 2 times a year for 3 years. Again, n, capital N here, is little n times t. Capital N here is your little n times t. Is the total number of times the interest compounded over the lifetime of the investment. The interest compounded semi-annually, twice a year for 3 years, so 2 times 3 is 6. Interest rate is 7. Present value, okay, that's what we're trying to figure out, guys, all right? Present value, we don't know. That's what we're trying to figure out, present value. Payment is 0. Future value is given. Future value is 11,000. You want to have 11,000 in 3 years. Future, in the future, FV, future value. P provides, C provides 2. And by the way, please only use the TID for calculator when you are confident and you know what's going on. If you are not familiar with this method, I'd rather you plug in a formula. Let's go back to solve for PV. The reason I put the 9999 is to hold the place for the variable that we are going to solve for. I put the 999 to remind myself because this number stands out, right? Alpha, enter. You need to put in 98 $148.51. So let's see, how do we round it? Let me emphasize. In the parentheses, it says round up to. I'm going to pause here for a little bit. This problem, it says round up to. Okay, you have to round it up to. Means you do not follow the normal rounding rule. You round up to, regardless the value of the digit after the rounding place. Rounding up to the nearest cent. So in this problem, we rounded up anyway, right? Because this is 7. Just to let you know, even here is not 7. Is it 4 or 3 or 2 or 1 or 0? You still have to round up to. You're going to round this 0 to 1. So A948.51. I have emphasized many times. $948.51. It doesn't matter this value equal to. Always round it up to, because that's what the question tells us to do. Round up to the nearest cent. All right? So question number 5, question number 6 is about compound interest. Question number 5, we are given the present value, we are looking for future value. Question number 6, we are given future value, we are looking for the present value. And that's it. And rounding, very important. It's okay. Thank you for letting me know. Next, question number 7, 2 parts. A, use the appropriate formula to find the value of the annuity. Okay, this is an annuity problem. B, find the interest. The information is in the box, in the table. Please take notes. Write down the payment. The periodical deposit means the payment, right? PMT, $2,500. Yeah, $2,500, $2,500 at the end of every 3 months. 3 months means by quarterly. The rate is 7.25%, compounded quarterly as well. Quarterly. So your little n is 4. T is 8 years. Yeah, please write down those key information. Your payment, PMT, $2,500. Your rate, R, 7.25%, 7.25%. Time is 8 years. Is quarterly, so your little n is 4. You write down those key information. If you want to use a formula, the first formula is what you need, okay? If you want to use, sorry, my bad. The second formula is what you need. In this formula, P here is PMT, $2,500. N here is 4 because quarterly. T here is 8 for 8 years. R here is 7.25%. So enter everything here, you can find the value of A. That's fine. If this method is good, is your method, then just use it. What matters is what really matters is you can get the answers right? And I'm gonna use TID for calculator for annuity. Capital N is your little n times your little t by quarter times 8. The capital N here is the total number of interest, a total number of the times your interest is compounded over the lifetime of the annuity. The annuity is 8 years. For 8 years, it is by quarterly, so 4 times 8. I just need to double check the key information. Yeah, 4 quarterly, 3 months, right? Quarterly, 8. And the interest rate 7.25. 7.25. Present value, how much? Okay, I need you to tell me what's the present value for annuity. Let's see if you paid attention, if you still remember. Yeah, what's the present value for annuity? Thank you, Jennifer. Exactly. For annuity, present value is 0. No money in the account. In this case, no money in the account until the end of the 3rd month. Until the end of the 1st quarter, your account is empty. PMT 2500. So if you want to play with the sign, is fine. But if this is burden to you, just do not worry about the sign at all. Okay, do not worry about the sign at all. So 2500. Let me double check. Okay, since this problem just enter values, you're gonna make sure the values you enter is correct. 2500. That's correct. Future value is what we're trying to figure out, right? Yeah, again, I put a 9999 to hold a place. And the P per Y, C per Y, your little n is a 4 because it's by quarterly. And the double check is an ordinary annuity, so END is highlighted. We never use begin. Never use begin. Even sometimes, what's wrong? I have emphasized so many times and you still don't hear me? Never use begin. We only use END. Go back to 9999, solve for future value, alpha, enter. Alpha, enter. Future value is more than, okay. Future, we don't know yet, right? So later we're gonna figure out how much money you have put in the account. So future value, you're gonna have, a lot of money, $107,142.97. See, how do we round it? The value of the annuity is, do not round until the final answer. Then round to the nearest, is round 2. So follow the normal rounding rule, dollar. Normal rounding rule, dollar. So this is 9, go up, round it up. 107,143. 107, double check, 143 is 4 times a year for 8 years, 32. Payment $2,500. 7.25% interest rate. Okay, looks good. Everything is fine. $107,143. Okay, that's part A. All right, now let's figure out the part B. How do we figure out the part B? I'm gonna do some scratch paper, all right? On your scratch paper, you're gonna write this down. Do not just depend on a calculator. Sometimes you need to write something on a scratch paper. So this is what you write. You're gonna write down money going out, and you're gonna write down money coming back or coming in. Okay, so money going out. Every quarter, you have to pay, you have to deposit $2,500 times 4. That's how much you pay in a year, right? Times 8. That's how much you have contribute to the annuity over the 8 years. So this is pretty convenient number. 2,500 times 4, that is 10 grand, 80 grand. Can double check. We can use a scientific calculator for that. So 2,500 every quarter times 4 is how much a year times 8. That's how much for 8 years. 80 grand. 80 grand. And the money coming back after 8 years. Yeah, in 8 years, when the annuity is mature and you get $107,143. Right? Yeah, so the money coming back is more than the money you have contributing to the account for sure. You want more. And the difference would be the interest. Let's see what's the difference. We're gonna use the money coming back 107,143 to minus 80 grand. 27,143. Use the answer from part A to find the answer. To find this answer, round to the nearest dollar as needed. So this number should be 80 grand less than this number. So 27,143. Okay, looks good. All right. Second type of problem that you may apply the app is the annuity problem. Remember, annuity problem, PV is 0. For annuity, PV, present value, is 0. Next, question number 8. To offer scholarships to children of employees, a company invests $8,000 at the end of every 3 months. So quarterly again, in an annuity problem that pays 11% compounded quarterly. Two parts. A, how much will the company have in scholarship funds at the end of 10 years? B, find the interest. Same with earlier, right? Same type of problem. Annuity and finding future value. So please write down the key information. Payment, 8,000. Payment, 8,000. Little n is 4 by quarter. 11% interest rate for 10 years, right? Yeah, those are key information. Okay, 8,000 quarterly, 11%. Okay, I got everything. So by quarter, 4 times a year for 10 years. So if the company drop a payment, make a transaction 4 times a year for 10 years, then the total number of transactions would be 40 transactions, right? Same with the number of interest is compounded. The interest is compounded quarterly, 4 times a year. For 10 years, 40. Double check is 10 years. At the end of 10 years, yeah. I%, 11%. Yeah, always double check your entry. 11%. PV for annuities is 0. Payment, 8 grand, 8,000. Future value is what we're trying to figure out. P per Y, C per Y is 4 because it's quarterly, and everything are correctly in place. And now you can solve for FV, alpha, enter. So in the future, they're gonna have over $500,000, $570,145. Let's see, how do we round? Do not round until the final answer, then round to the nearest dollar as needed. Dollar. $570,145. This one is less than 5, so round it down. Get rid of those. $570,145. Double check your entry. Yeah, always double check, triple check. 570145. Okay. For interest, use your scratch paper, please. For interest, use your scratch paper. So we're gonna do some work on the scratch paper. Same with earlier. Write down money going out, and the money coming back. Money coming back, we just figured out, is $570,145. Money going out, so $8,000 every quarter times 4 is every year times 10 is for the 10 years. It's also very convenient. It's going to 320 grand. We can use a calculator. So 8,000 times 4 times 10 320 grand, 320 grand, 320, 1, 2, 3. Okay, the money coming back is a lot bigger than that. The difference is the interest. $570,145. Use that to minus 322. 320, sorry, 320. 1, 2, 3. 250145. 250145. Double check. So 320. 320. 250145. Okay, that's correct. Question number 7, number 8 are the same type of problem, annuity problem. And this is also an annuity problem, but instead of looking for the future value of the account, we're looking for the periodic deposit to reach a certain financial goal. Let's read the problem. Use the appropriate formula to determine the periodic deposit. How much of the financial goal comes from deposits and how much comes from interest? If you are using the formula, you're going to use this formula, okay? This one. P here is the payment. A is the future value, the financial goal. R is the interest rate. N is the, in this case, is quarterly, so N is 4. T is how many years? 6 years. T equals 6. Yeah, so you use this formula. Or we can use a formula. We can use a TID for calculator, right? Yeah, please write down the key information. The rate, 3.5%. Quarterly, so your little n is 4. Your T time is 6 years. Your financial goal is 10 grand. Okay, with those, we can use calculator. 4 times a year for 6 years, right? Yeah, double check. Quarterly by quarterly, so 4 times a year for 6 years. 4 times 6 is 24. That's correct. Interest rate 3.5. 3.5. Interest rate 3.5. PV always 0 for annuity. Payment we don't know. Payment is the number we are trying to figure out. So put a 9999 to hold the place. Remind us gonna go back later to solve for PMT. Future value, you want to have 10 grand. Let's see if it's 10 grand. Yeah, 4 zeros. And P provides, C provides a 4. This is just, I think it's a coincidence. Always 4. Your question might not be 4. For some reason, what I see is here is always, so far, everything is quarterly. Annuity. Quarterly, so P provides, C provides a 4. END is highlighted. Okay, looks good. Everything's fine. Okay, we're going to solve for payment. Alpha, enter. Let's see how do we run it. Very, very important. Let's read this sentence in the parentheses. Do not round until the final answer, then round up to the nearest dollar. They said round up. We would have to round it up. So since this number is 2, if we follow the normal rounding rule, we're going to round it down, right? But the question specifically tells us to round it up. We have to round it up. So it doesn't matter what's this value equal to. Always round it up to $7. Okay, the 26 cents round up to $7, $1. So here it becomes 7. 377. $377. 377. If you mess up this part, you don't have the point, right? You lost the point. This exam is supposed to be easy because you can depend on the calculator significantly. Suppose you understand what's going on. All right, let's see part B. Part B asking how many dollars from the deposit. Okay, we can use the scientific calculator. You deposit $377, right? Yeah, use the answer from part A. So from part A, we know every quarter you deposit $377. 377 times 4, that's how much you deposit for a year. And then times 6, that's how much you deposit for 6 years. So that's the money coming from you, from your pocket. 9048. 9048. Double check. 9048. And that's how much money from you. And the rest of the money is the interest, right? Use the 10 grand to minus the money you put in. 1, 2, 3. That's the money that's the money coming back. Use the money coming back minus the money you put in. 9048. The interest is shy $1,000. 952. All right, because the rate is pretty low, so not a lot of interest, even for 6 years. Next, suppose that you borrow $13,000 for 3 years at 6% toward the purchase of a car. Use this formula to find the monthly payments and the total interest for the loan. Okay, this is a loan problem. I mentioned earlier, there are 3 types of problems that you may apply the TBM solver in the TI-84 calculator. This is the 3rd type of problem. The 2nd type is the annuity. We have already just covered that. The 3rd type is the loan. Car loan, home loan, same thing. So write down the key information. N is always 12 because you pay by month. You need to borrow the loan amount 13 grand for the car, $13,000, 13,000. Rate is 6%. If you wanna plugging in, yeah, you can plugging in, no problem. You're plugging in. P here is the loan amount, is 13 grand. R is 0.06, N is 12, T is 3 years, so T is 3. Okay, so those information just plugging in. Or you can use a calculator, right? Let's use the TI-84 calculator. Capital N, 12 times 3. You're gonna pay back the loan over time by month. So 12 times a year for 3 years. So 36. You expected to pay 36 times, right? 3 years. Yeah, 12 times 3, 36. Interest rate 6%. 6%. Okay, PV, guys. PV for loan. PV for loan is the loan amount. Is the money originally the lender give you. 13,000 in this case. All right, PV is not 0. PV is 0 for annuity. PV is the loan amount in the case of a loan problem. Payment is what we're trying to figure out, I believe. Okay, anybody can tell me what's the future value for the loan? Thank you, Ashley. Exactly, 0. Awesome. Future value is 0. Yeah, for loan, future value is 0. For annuity, present value is 0. Just remember those. P provides, C provides 12. Go up to solve for payment. Yeah, let me double check 3 years loan. 6%. 13 grand. Oops. 13, yeah, you borrow 13 grand. Okay, so payment, alpha, enter. Let's see how do we round. Follow the instruction. Do not round until the final answer, then round to the nearest cent. Round to the nearest cent. Cent. So 5 is bigger than 5. Bigger than or equal to 5, so round it up. 49 cents. $395.49. Double check. 395.49. Okay. Part B, total interest. What's the cost of the loan, right? Okay, let's we're gonna do some scratch paper. Do some work on a scratch paper. So write this down. Money coming in is a loan, so coming in first, right? And then money going out over time. Money going out over time. So going out monthly payment, $395.49 times 12 times 3-year loan. And that's how much money going out. Money coming in, the very beginning, they give you 13 grand. That's money coming in. Let's calculate how much money going out. We use the answer, from part A. So we use answer from part A, $395.49 times 12 times 3. Yeah, that's the money going out, right? The money going out must be bigger than the money coming in because the extra is the cost of the loan. So use this number to minus 13 grand, minus 13 grand. And we have this number. Let's see if I can copy paste. $1,237.64. That's the interest. That's the cost of the loan. Double check. 1,237.64. Right? Yeah, so that's a loan problem. Loan problem. Crystal. Oh, I'm recording the class. You can watch the recording later. Let's see, almost 1 hour. Almost 1 hour. We did 11 problems. I think we should be able to finish everything on time. Question number 11. Suppose that you decide to buy a car, $27,635, including taxes and the license fees. You save the $6,000 for a down payment, and you can get a 4-year car loan at 5.56%. Use this formula to find the monthly payment and the total interest. Similar with the previous problem, but a little different. The difference is this time you have a down payment, $6,000. So your loan amount is not the price of the car. It's the amount of money you need to borrow from the lender. So use the price minus the money you have. 21 grand, 635, right? Yeah, so have that ready. So present value of the loan amount is not 26 grand, 21 grand. 21 grand, how much? 21 grand, 635, 635. All right, double check. Let me double check. 27 grand minus 6 grand, 27 minus 6, 21. 21 grand, 635. Yeah. And interest is 5.56. 5.56. Capital N, 12 times a year. How many years the loan is? 4 years times 4. Okay. So want to double check everything is fine. Want to double check. 12 times a year for 4 years, so 48%. Interest rate 5.56. PV loan amount is not 27 grand, it's 21 grand because you have 6 grand down payment. 21 grand, 635. Future value is 0. 12, 12. Okay, everything's fine. Alpha, enter. Rounding. Round to the nearest cent as needed. So this 5 is bigger than 5, bigger than or equal to 5, round it up. 50375. 503. Double check the entry. $503.75. Okay, correct. Interest. Yeah, let's see how much you been paying. You will be paying the lender over the 4 years. Okay, so every month you pay $503.75. They ask you to use the answer from part A. You would have to do that. Okay, $503.75 times 12 times 4, 4-year loan. So that's how much money you will pay, end up with paying the lender. Use that to minus the money you owe. The money you owe is 21,000. You should have that. We should have that on the scratch paper. Use the price minus the down payment. So 7 minus 6 is 1, $21,635. The interest is 2545. Okay, right? And that's it. Loan problem. This one is to buy a house. Yeah. Down payment. Yeah, we're gonna do by parts. Find the required down payment. 20% down payment. 20% of the price of the house. The price of the house is 141 grand. Let's see how much is the 20% of that. 141,000 times 20% times 0.2. Down payment is 28,200. 28200. 282. $28,200. 28,000. Okay, that's part A. Part B. Find the amount of the mortgage. That will be the price minus the down payment. The price is 141 grand minus down payment 28200. 112,800. 112,800. So that's the loan amount. How much must be paid for the 3 points at the closing? 3 point is 3% of the mortgage, okay? And you have the mortgage found in part B. So 3% times the loan amount. This is the loan amount in a calculator. 112,800 times 3% times 0.03. 3%. Closing cost 3384. That's the closing cost. Find the monthly payment. Okay, monthly payment. We're going to use a calculator for that. Let's see how many years loan this is. How many years? 7%. 30 years. Yeah, 30 years. So here is 12 times 30. 12 times 30. That's 7%. Let me double check. 7%. Yeah, 7%. And the loan amount 112,800. 112,800. $112,800. Payment is what we're trying to figure out. Future value is 0 for the loan. P provides, C provides 12, E and D. So alpha, enter. 30-year loan, 7% loan amount. Okay, so every month you need to pay that much. Let's see, how do we round it? Round 2, the nearest dollar is needed. Round it down, 750. 750. 750. Oh, one more. Find the total cost of interest over 30 years. Okay. So every month you pay $750 times 12. That's how much you pay a year. Times 30. That's how much you pay over the 30 years, right? And that's the money you end up with paying the lender. Use that to minus the mortgage, which is 112,800. The difference is the interest. The interest is more expensive than the house. 157,200. And that's it. Part A through Part E. And mortgage, this one is time consuming. Number 13. I hope should be have questions simpler that we can get it done before 3:10 today. Question number 13. The price of a home, 180 grand. Banker requires 15% down. The buyers offered two mortgage options. 15-year fixed 8%, 30-year fixed 8%. Calculate the amount of interest paid for each option. How much does the buyer save in interest with the 15-year option? Use the following formula to determine the regular payment amount. Okay, find the monthly payment for 15-year option. Yeah, you can use a calculator. You can use the formula. No problem. You have to figure out what is the mortgage. Okay, your mortgage is not 180,000. Your mortgage, your loan amount is 85% of that. Okay, yeah, can we agree on that? So on the calculator, on the scratch paper, please write down loan amount is, so you down payment 15%, right? You pay 15%, so you need to borrow 85%. 85%. You have 15% already. You only need to borrow the rest 85%. 85% 0.85 times 180.23. So this is the loan amount. Please remember that. This is the loan amount. Please remember that. 153,000. Okay. I'm gonna keep this in my scientific calculator. $153,000. Let's see. This is 15, 8%. Calculator. 15 years, so 12 times 15. 15 years. What is the interest rate? 8%? 8%. Loan amount, PVL loan amount is in my scientific calculator. 153 grand. 2, 3. Everything the same, right? 0, 12, 12 end. So we're going to solve a payment for 15 years option. See, how do we round it? How do we round it? Round to the nearest dollar, okay? Round it down. 1,462. $1,462. That's the monthly payment for the 15-year option. It's a lot of money. And what's the monthly payment for the 30 years option? All we need to do is to fix here. Instead of 15 years, this time is 30 years, so times 30. Everything else the same. And then we solve for a payment. Alpha, enter. Yeah, go down. To the nearest dollar, 1123. Nearest dollar. To the nearest dollar. Double check. This is bigger than 5, so round it up. $1,123. So that's part, yeah, that's the second part. Third part, calculate the total cost of interest for both mortgage options. How much does the buyer save in interest with the 15 years? Okay, we are going to take a different way to find the difference of interest, right? The difference of interest. Okay, so yeah, we would have to do some scratch paper. Let's do that. To make it clear, I'm gonna show you on a scratch paper. So the 15 years payment option, 15-year option, you pay $1,462 every month times 12 times 15. That's how much you end up paying the lender of the 15 option. Let's figure that out. See how much that is. $263,160. $263,160. And then for the 30-year payment option, every month you pay 1123 times 12 times 30. Let's see how much is that. For 4,280. $404,280. Okay, so you see the difference, right? You don't have to worry about money coming back. The difference happens the money going out. So let's take the difference of those two values. Use the bigger number minus the smaller number, 263,160. 141,120. That's the difference of the cost. That's a lot, right? 141,000. The house is only 180,000. Normally, if the time is longer, the interest rate is supposed to be lower. All right, so that's it. Question number 14. See if they, oh, okay, this one takes a little bit of time. Take a little time, yeah. Do you guys, to do this problem, firstly, you need to know King Henry. Okay, let me see. King Henry, let me write down the Q. King Henry died Monday drinking chocolate milk. You need to remember this, all right? You need to remember this. You need this for the exam. So this is km, km, this is a hm, hecto, this is DAM, okay? Drink is DM, decimeter. This is meter, the basic unit. cm, this is millimeter. Yeah. You need to know this chart. And from decimeter to inch, we are not given the equivalence between decimeter and inch. So we need to build a bridge. The bridge is going to be the centimeter, okay? We're going to go from 22 decimeter to centimeter first. And you look at this from DM, from DM here to centimeter, go to the right one time, right? Go to the right one time. DM to centimeter, DM to cm, one time to the right. So you're gonna move the decimal point in 22 to the right one time. So you have 220. So you're gonna have 220 cm. You don't enter those, okay? I enter this just to show you. I'm gonna erase the parts that not needed later. And then we go from centimeter to inch. And the equivalence between centimeter and inch is given. The first one, 2.54 is the conversion factor. There are 2.54 centimeters in an inch. Inch is a bigger unit, right? Remember that? I said inch is from the tip of finger to the first knuckle. That's about 1 inch. And centimeter is smaller. is from your fingertip to the end of the nail. You must remember this if you paid attention. So inch is a bigger unit, so we need a smaller number here. How do we get a smaller number? We divide 220 centimeter by the conversion factor 2.54. How do we round it? Round to the nearest hundreds, so keep 2 decimal places. 4 is less than 5, so round it down. 86.61. 86.61, that's the answer, okay? Those are just my notes. You're gonna erase those things. You only keep the part, you only enter the final answer. Yeah, that's supposed to be on a scratch paper. 86.61. 220 divided by 2. Yeah, correct. Next. From inch to dam. Okay, how about this time we go from inch to centimeter and then from centimeter to dam. That's the plan. Centimeter is a smaller unit from the fingertip to the end of the nail, right? So the number needs to be bigger. So this time we multiply by 2.54. We multiply 240 by 2.54. 609.6. That's how many centimeter. Okay, that's how many centimeter. Let's see from centimeter to DAM. Centimeter to dam. From centimeter to DAM. This DAM is centimeter. 1, 2, 3. 3 times to the left. So this number, this many centimeters. Move the decimal point to the left 3 times. 1, 2, 3. So it's going to be 0.6096. 0.6096. Double check the entry. 1,000 times smaller than that. 6096. Both questions need a bridge because the equivalents are not given directly. So you need to know how to build a bridge. Very similar with the actual problem. And this one from feet to meter. Do we have feet meter? No, we have feet and a centimeter, right? Okay, same thing. Build a bridge, use the centimeter as the bridge. Let's go from feet to centimeters first. Feet, you know, you go to Subway, the 1 foot long sandwich, that's how much for 1 foot. It's a lot bigger than 1 centimeter. Again, centimeter from your fingertip to the nail, end of the nail. Centimeter is a smaller unit, so we need a bigger number in front of it. So we're going to multiply 11 by the conversion factor. The conversion factor is 30.48. So use 11 feet to multiply 30.48. Conversion factor between foot and centimeter, and that's how many centimeters. Okay, centimeter is 100 times smaller than meter. Yeah, centimeter is a smaller unit. So in order to convert to meter, as you can see, from centimeter to meter to the left twice. From centimeter 1, 2. From centimeter to meter to the left twice. So the answer is going to be 3.3528. Let me know if it's clear. Might be a little bit fast, but if you paid attention last class and you practiced the method I taught, 3.3528. Let me double check. 11 feet times 30.48. That's how many centimeters. Centimeters, go to the left, divide by 100. Yeah, that's correct. Round the final answer to the nearest hundreds. Oh, oops, look at this. Round the final answer to the nearest hundreds as needed. Round all intermediate values to the nearest hundreds as needed. So we need to keep 2 decimal places. That means we're gonna get rid of that. Right? Yeah, get rid of that. 3.35. Yeah, rounding is also important in chapter 9. You're gonna have to do the system asks you to do, otherwise you just lose the point. Round the final answer to the nearest hundredth as needed. Round all intermediate values to the nearest hundredth as needed. Yeah, good. You did a great. Next. Milliliter to cubic centimeters. Let's see. The first equivalence, as you can see, 1 cubic centimeters is the same with 1 milliliter. Yeah, again, 1 cubic centimeters is the same with 1 millimeter. You might have also heard of cc, right? cc. Yeah, the people need to get injured, need blood in, you know, how many cc? That's cubic centimeters. Same with those. Then we don't have to convert the same number. 381. Round to the nearest hundreds as needed. We don't need that. Yeah, because milliliter is the same with cubic centimeter. They are equivalent. The volume in cubic centimeter is the same with 1 milliliter capacity. Same thing. Kiloliter to cubic decimeter. Do we have the conversion? Kiloliter. We don't have. Oh, here, this one. Okay, we're gonna build a bridge. All right, guys, we're gonna build a bridge because cubic decimeter, as it shows, is the same with liter. Okay, we're going to use liter as the bridge. Kilo, I mentioned this. Kilo in metric system means 1,000. 43 kiloliter literally means 43,000 liter. Okay, so kilo here translated to 1,000. 43 kiloliter is 43,000 liters. So 43,000 liters, the same with 43,000 cubic decimeter. So same thing. All right, same thing. Okay. Use the table of English and metrics. Okay, this one from milliliter to teaspoon. See, milliliter to teaspoon. Milliliter to teaspoon. This is the first one. From the equivalence, those formulas, we can get a lot of information, important information. Milliliter to teaspoon. Since 5 is bigger than 1, milliliter is a smaller unit. Compared with teaspoon, milliliter is smaller unit. How many times smaller? 5 times smaller. So the number in front of teaspoon, okay, so teaspoon is a bigger unit. The bigger unit need a smaller number in front of it. So how do we make that number smaller? We divide it by 5. So 12 divided by 5 is 2.4. 12 divided by 5, 2.4. Because from the equivalence we can see teaspoon is a bigger unit, 5 times bigger than milliliter. So the number in front of it has to be smaller. How many times smaller? 5 times smaller than 12. So divide 12 by the conversion factor 5, we get 2.4 teaspoons. Round to 2 decimal places. Okay. Use the given equivalence along with dimension, don't worry about that, to convert a given unit. Okay, 380 pounds to kilogram. Okay. From the equivalence, we should know pound is a small unit, kilogram is a bigger unit because 1 pound is only make 45% of a kilogram. 2 pounds only make 90% kilogram. 2 pounds is not even 1 kilogram, only 90% of a kilogram. So kilogram is a bigger unit. We can also know that by looking at the numbers in front of the two units. 0.45 is smaller than 1. This number is smaller, so the unit is bigger. Kilogram is a bigger unit, okay? Kilogram is bigger unit, so we need a smaller number here. We need a smaller number here. We either multiply by 0.45 or divide by 0.45. You figure it out. We should multiply, okay? Kilogram is a bigger unit. We need a smaller number here. We need a smaller number here. To get that smaller number, we multiply 380 by 0.45. If you divide it by 0.45, you will see you're gonna get a bigger number. All right, 171. 380 pounds is 171 kilograms. Yeah. Pound to grams. Pound to grams. Okay. We don't have to worry about that. We have a pound and a kilogram. Let's build a bridge. The bridge is going to be kilogram. Let's go from pound to kilogram first. 69 pounds to kilogram. Kilogram is a bigger unit, so we need a smaller number. Times 0.45. That's how many kilogram? Kgram, kilo. Kilo means 1,000. So kilogram means times 1,000 grams. So it's hold on. Yeah, 31. Yeah, 31050. 31050. Double check. 31050. 69 pounds times 0.45 is 31.05 kilogram times 1,000. That's how much grams in it. Okay. Kg to pound. The conversion factor is 0.45. Pound is a smaller unit. Pound is a smaller unit, so we want a bigger number here. Conversion factor is 0.45. If you multiply by 0.45, you get a smaller number. So if you want a bigger number here, you're gonna have to divide it by. So 460 divided by 0.45. How do we round? Round to 2 decimal places. So 1022.22. 1022.22. Okay. Let's see. Gross income. Oh, the tax. Find the gross income, AGI, taxable income. Base the taxable income on a greater of a standard deduction or an itemized deduction. A taxpayer earned wages 42,000. Received 300 in interest from a savings account. So 42,000 plus 300. 42,000 and $300. And so the rest of the information has nothing to do with the income. The gross income, total income, 42 grand, 300. 42 grand, 300. AGI, what's the adjustment? Read the question thoroughly. He contributed 7,800 to a tax-deferred retirement plan. That's the adjustment. And he had a itemized deduction totaling, so that's deduction, standard deduction. So only one adjustment. So we're going to use gross income to minus adjustment. 7,800 is AGI. 34,500. 34,500. 500. Okay, 34,500. So that's AGI. Use AGI to minus deduction, we get a taxable income. For this taxpayer, his itemized deduction is 6,000. Shark 7,000 is smaller, less than standard deduction. So he should use standard deduction. So we're gonna use standard deduction. Use the AGI to minus standard deduction, $12,550. 550. 21,950. And that's the taxable income. All right, taxable income, not bad. Very basic. This one, FICA. Use 2021 FICA tax rates shown to answer the following question. If a taxpayer is not self-employed, okay, not self-employed means you only need to look at the first column, and earns $141,000. Okay, this one is easy. It's easy because the gross income is lower than the maximum of the first bracket. 141,000 is lower than the maximum of the first bracket. What are the taxpayers' FICA? All we need to do is to use 7.65% to multiply with the gross income. 7.65% divided by 100. That's the decimal equivalent to the percent. Multiply by gross income. $141,000. So the FICA is 10 grand, $786.50. Round to the nearest cent I needed. Just like that. Important thing we need to know. There are two brackets, but there's only one bracket applied to this taxpayer because this taxpayer's gross income is lower than the maximum of the first bracket. So we only need to apply the first rate. It's a very simple percent problem. This taxpayer is self-employed. If a taxpayer is self-employed, we look at the third column. The rate is 15.3% for the first $142,800. Net profits 2.9% for the additional. So this person whose gross income is 151. Okay, this one we need to do some scratch paper. Firstly, we know we're going to look at the last column because the person is self-employed. And this person going to have both rates because his gross income go beyond the maximum of first bracket. So let me write down the two brackets for him. From the first dollar to the $142,800, $800. And then from $142,801 to, we're going to adjust, modify the maximum of the second bracket for the taxpayer is his gross income, $151,000. All right. The first bracket, 15.3%. The second bracket, 2.9%. Okay, so two buckets. In the first bucket, we're going to have $142,800. In the second bucket, we are going to have this number minus this number. I mentioned that before, right? 151,000 minus 142,800. That is I want to use the TID for calculator. The first rate is 15.3%, so 0.153 times the money in the first bucket, which is 142,800. And then plus the second rate is 2.9%, 0.029 times the money amount in the second bucket. The second bucket we have 151,000 minus the money in the first bucket, 142,800. A benefit of doing this is I can check my entry. At once. Okay, the FICA is 22086.2. Double check. (22086) 22086.2. Okay, that's correct. Round to the nearest cent. That's good. This one, simple interest. All right. The principal P is borrowed at a simple interest rate for a period of time T. Find the simple interest owed for the use of the money. Assume 365 days in a year. All right. P, R, T, multiply them together. However, T cannot be 9 when you calculate because the time T has to be time in year. Anybody can tell me how many years in 9 months? How do we convert 9 months to year? How do we convert 9 months to years? How many years in 9 months? Are you guys there? Oh, I shouldn't actually responded. Divided by 12. Awesome, exactly. Is 3 quarters, right? Yeah, 3 months a quarter, another 3 months, 6 months, another 3 months, 9 months, so 3 quarters. Very good. So when we process this problem, we multiply the principal, 7 grand, 2, 3, times the rate, 3.5%, 0.035. And that's how much interest for 1 year, times 0.75. That's how much interest for 3 quarter. $183.75. Do not run until the final answer, then run to the nearest cent. Okay, very good. This one, simple interest because it's loan. In order to start a small business, the student takes out a simple interest loan for $2,000 for 6 months at a rate of 11.25%. How much interest must the student pay? Okay, let's see. He borrowed $2,000. Multiply that by the interest rate, which is 0.1125. That's how much interest for 1 year. That's how much interest for 1 year. Okay? Loan amount times annual interest rate gives the interest amount for 1 year. But this student only take the loan for half a year, 6 months, half a year. So we have to divide by 2. 112.5. That's the interest. So in half a year, he gonna pay back the $2,000 and the interest. So he pay more than the lender gives him, of course. So mark up. The future value is going to be 2,000 $112.50. 112.5. Okay, very good. Add on top of $2,000. This one is, let's see. We should be able to finish. Yeah, we're on the track. The principal represents an amount of money deposited in a savings account, subject to compound interest at the given rate. Answer part A through and B. Find how much money there will be in an account after the given number of years. After 5 years, compounded monthly, rate 3.5%, principal 6,000. So this is a compound interest problem. You may use a calculator. You may use the formula, first formula, or we can use TID for calculator. Find the future amount after 5 years. Okay. See, 5 years monthly. Go to apps, finance, TBM solver. So 12 times a year times 5. That's how many times the interest is gonna compound over the 5 years, right? 12 times 5. 12 times 5. I% 3.5. Interest rate 3.5. Ooh. Yeah, 3.5. And the PV is a lump sum investment deposit here. Original principal 6,000. Oops. 6,000. Payment is 0. Okay, guys, remember, if we do annuity, PV is 0. If we do loan, future value, FV is 0. If we do compound interest account, payment is 0. Future value is what we need to find out. P per Y, C per Y is 12. END is highlighted. Everything looks good. 12 times a year for 5 years, 3.5. Just double check. Yeah, it looks good. So solve for future value. You're going to have that much money in the future in 5 years. How do we round it? Round it to the nearest hundredth. So the nearest cent. The nearest cent. 6 is bigger than 5, so round it up. $7,145.66. Double check your entry. Okay. Find the interest earned. Okay, we're gonna do the interest. The interest. This one is easy. So you put in 6,000. In 5 years, you have this more than 6,000. The difference, of course, is gonna be in interest, right? Use $7,145.66 minus $6,000. 1145.66 is the number is also convenient. Just subtract 6,000 from this number. 1145.66. Number 29. How much money should be deposited today in an account that earns 3.5% compounded monthly, such that it will accumulate 12,000 in 2 years? Compounded monthly. So you can use this formula, the second one, because this time the future value is given. You are looking for the original principal, or we can use the TID for calculator, right? By month. Okay. So in 2 years, 12 times a year times 2. I think it's 3.5 also. Present value is what we're trying to figure out. Future value, how much you want to have? You want to have 12 grand. 12 by month. Let me double check the entry. Compounded monthly, so for 2 years only, 24 times. Interest rate 3.5%. In the future, you want to have 12 grand. Okay, very good. Everything looks good. Go back to solve for present value. Alpha enter. Let's see how do we round it. Round up to the nearest cent. So this one, 6 cents, round up to 7 cents, 87 cents. 11189. Double check. 87. Be very careful. Double check again. $11,189.87. 11189.87. Okay, looks good. So that's the future value. No, that's the present value. My bad. This is the present value. You should deposit this much in order to have 12 grand in 2 years, right? Okay, so that's it. Number 30, an account has a rate of 3.9%. Find the effective annual yield if the interest is compounded monthly. This is the problem. You do need a formula. Calculator doesn't help you. We don't have an app can handle that. You do need a formula. Which one? This one, Y. Capital Y represents yield. Capital Y represents yield. Okay, so monthly, compounded monthly, so n equals 12. The nominal rate, R here is the nominal rate, 3.9%. And you're plugging in to find the effective rate. Okay, I'm going to do that on the scratch paper. Okay, this is the only problem. You have to use the formula. The formula is Y equals 1 plus the compounding factor, and then to the power of n and minus 1. Here n is 12 because it says monthly, compounded monthly. The nominal rate is 3.9%, which is 0.039. We're going to plug in 1 plus 0.039 over 12 to the power of 12 and then minus 1. And then I like to use the TID4 calculator to handle the calculation as well. Because to the power of 12, a scientific calculator would be not convenient to raise a base to the power of 12, right? So I'm going to use a calculator, knowing the correct answer is going to be a little bit more than 3.9%. The effective rate always bigger than the nominal rate, but not a lot bigger. It's just a little bit bigger. So let's figure it out. Use the calculator. Start a parenthesis, 1 plus. Start another parenthesis. I'm going to use that to frame the monthly interest rate. 0.039, that's the annual interest rate, divided by 12, that's the monthly interest rate. So this set of parentheses, I have the monthly interest rate. And now I close the compounding factor. 1 plus the monthly interest rate is the compounding factor. Raise the compounding factor to the power of 12. And then minus 1. And that's the rate, effective rate in decimal, multiplied by 100. And then attach the percent sign. So we're going to have a percent sign here. But we need to round the number. This is the number we need to round. Let's see, how do we round it? Round to the nearest hundredth as needed. 2 decimal places. So 0 is going down, right? So 3.97. 3.97%. 3.97%. That's the effective rate. This is nominal rate. As I mentioned, when the little n is bigger than 1, because of the compounding effect, the actual yield, the effective rate, is bigger than the nominal rate because it take the compounding effect into consideration, but not a lot bigger. As you can see, this is very reasonable. It's a little bit bigger, right? A little bigger, very close, bigger. The last question. Okay, we have enough time to get it done. Perfect. You would like to have $4,500 in 4 years for a special vacation following graduation by making deposits at the end of every 6 months in an annuity. So this is an annuity problem that pays 5% compounded semi-annually. Answer part A and B. How much should you deposit at the end of every 6 months? Okay, we're going to use the TID for calculate the TVM solver. Let's remember those key information. Financial goal is set 4,500. Time is set in 4 years. Rate is set. You found an account, the lender 5%, compounded semi-annually. Okay? Yeah, we can go back later to check. 4 years. Okay, so go to apps, finance, TVM solver. Semi-annually, right? Twice a year times 4 years. Double check. Semi-annually. Semi-annually. So 2 times a year times 4, 8 times. Interest rate 5%. Present value, annuity, present value is always 0. Payment is what are we trying to figure out? Future value, how much do you want to have? You want to have 4,500. Double check, triple check your entry. P provides C provides 2, not 12 anymore, because the interest is compounded semi-annually, so N equals 2. Also, you only deposit 2 times, pay twice a year. Let's double check. Semi-annually for 4 years, so 8. Interest rate is 5%. You want to have 4,500 in 4 years. Okay, everything looks good. Go back to solve for payment. See how do we run it. Do not run until the final answer. Then round up to the nearest dollar. Round up to the nearest dollar. Even here's a 1, we round it up. The 1 dime-ish, round up to $1, so $6. 5.16. 5.16. That's your periodic deposit. How much of the future 4,500 comes from deposit and how much from the earning? Okay. Let's see, you pay 516 every half a year, right? So times 2, that's how much you pay for a year. Times 4, that's how much you pay the lifetime of the annuity. You pay that much. But you will have 4,500 more than that. So the difference would be the interest, right? Yeah. So how much from you? 4128 from you. 4,000. $4,128. And the difference, use 4,500 to minus 4,128, 372. 372. Interest is not very much because interest rate is 5%, not bad. Probably because semi-annually, twice a year only, over 4 years. So $372 from the interest. Use the answer from part A. $. Okay. Let's see how well we did. Oh, we did 100%, right? All right, guys. Do you guys have any questions? Feel free to ask before 3:10. If you miss any parts, I'm recording the class. You can always go back to watch the recording. Did you get my message? Yeah, I emailed you back. Yeah. Are there as many questions on test? Oh, so I think there are 19 problems or 18. I don't remember exactly. I'll post it in the announcement. Know about my login. Oh, let me read it now. Oh, you want me to fix your attendance? Okay, I got you, Crystal. Let me fix your attendance. Which one? This one? Also, guys, please let me know before you leave. Please let me know when do you want me to set the due date for exam 2? When do you want me to set a due date for exam 2? You can start from tomorrow. So when do you want to due? Type your opinion, your preference. Okay, it's fixed, Crystal. Thank you for letting me know. It's fixed. No worry about that. No problem. Can you set the due to be April 15, April 5? Okay. Yeah, April 5. I can do that now. April 5. So let me start the announcement, then later I'll finish later. So this is our class. This is the information about exam 1. So we're gonna have exam 2. Exam 2 arrangement, time window. You can, how about tomorrow? Today, you don't have to do it today. So tomorrow, March 25th to April 15. Yeah, so I'll take the one that the farther away. So 15 sounds better than 5th, right? Yeah, actually you just whenever you want to take, you don't, it's not on that day, anytime before that day. 15 sounds good. Yeah, 15 sounds good. Let's do April 15. Okay, April. Where's my April 15? So April 4, 15. Oh, 15. April 15. Anytime the testing center is open, you can go there. If you need to take it on Saturdays, make sure you make an appointment with the Southeast testing center ahead of time. April 15. Location, TCC testing center. If you live more than 50 miles away, please email me again to remind me to arrange your exams. Yeah, I should have wrote it down. I apologize. So please be nice. Kindly just email me one more. Just shoot me an email. Remember, I cannot make it a testing center TCC because I live far away. We find another institution. Okay. Time limit 80 minutes. Prerequisite pass the review with 70% above, right? Yeah. Please do not forget that. You need the green flag needs to go away. The green flag needs to go away before you take the exam. All right? Yeah, time, location, time limit, chapters, covers chapters 9 and 8 and 9. Cover chapters 9, 8 and 9. 8 and 9. Yep. Let me send an email also to you. Email announcement, send a copy of email. Okay, and then submit. Chloe, can you use an online calculator? No, I'm sorry. You can't because the lockdown browser, when you go to testing center, they have a lockdown browser. That means everything else is blocked. You can't use a online calculator. But on each campus, the tutoring center, math lab, they have a TID for calculator. I remember because I only taught in Metro and the Northeast. Northeast have like a shy 20. That's what I was told. It might not be the exact number, but in Metro, I remember they have 30 TID for calculator, almost like around 30 and on the wall, and you can check out for that day. Will the due date be changed on? Yeah, I will do that soon. Yeah, I will do that soon. I'll do that later. It's fine right now. I'll do that later. No problem. Yeah, I'll remember to do that for sure. Thank you for reminding me. Yeah, that's calculator. Yeah, calculator is very useful, very helpful for chapter 8. Ashland to complete the due date. Yeah, I will change the due date for sure. All right. Do you guys have any questions? I would recommend rewatch the video. Do you know where to find the video? Let me show you. So this is our course shell, right? You see a virtual classroom. You click that, and then you will see a sandwich, 3 bars. You click that, and then you see recordings. You click recordings, and those are the recordings from the past. And for today is not there yet because we haven't finished the class yet. Once we finish the class, maybe wait a little bit. It will be uploaded in Blackboard. I can't think of any more questions. Yes, please. Yeah, if you have further questions, please feel free to let me know. All right, guys. So that's everything for today. If you have questions, you can stay and ask the question. If not, I'll see you on Wednesday. On Wednesday, we're gonna start a new chapter. Okay, you have a good one as well, Jack. You guys are welcome. Thank you, Angie. Bye. I'll see you on Wednesday, everybody. See you on Wednesday. Bye, Crystal.